Welcome to MrCScience.com's video on atomic mass. We're going to talk about the mass of atoms today. So let's take a look at our periodic table of elements. If you got it handy, pull it up. Okay, take a look at carbon. Carbon has an atomic number, the number on top, of 6. What does that atomic number stand for again? It stands for the number of protons. Now on the bottom here is the 12.0, that's the atomic mass. I can't spell. There we go, atomic mass. Atomic mass, as we've said before, is the number of protons plus the number of neutrons. But it becomes useful in chemistry for other reasons as well. Okay, we can use it to in our actual chemical problems and determining how much of each atom we need. So the atomic mass of carbon has been experimentally derived at 1.99 times 10 to the negative 23rd grams. So the atomic mass of carbon is extremely tiny. So now the AMU was derived originally from hydrogen, but they use carbon now as closer. But so one atomic mass is 1.99 times 10 to the 23rd grams, but we give carbon an AMU of 12. So we want to get grams per AMU, or atomic mass is, sorry, getting ahead of myself, is often written as AMU. It's a derived unit that we can use to relate atoms to each other. So if 12 AMU weighs 1.99 times 10 to the negative 23rd grams, let's use a little conversion here. We want to get grams per AMU, so yeah, if we divide by 12 AMU, we get, you arrive at 1.66 times 10 to the negative 24th grams per AMU, and you can use that across all your table. If you look at hydrogen, it has an atomic mass of 1, so one atom of hydrogen weighs 1.66 times 10 to the negative 24th grams. So this can be helpful in relating to other chemical problems. So let's go ahead and see how this relates. We can use that to derive our molecular mass. I should probably do that using a real font, but molecular, is that spelled right? Molecular, that's an A, that's what I thought. Molecular mass. So let's take something simple. First of all, let's take water, H2O. Its molecular mass, we've got 2 hydrogens with, if we look at our periodic table of elements, 2 hydrogens have a mass of 1.01. So we got 2 hydrogens times 1.01 AMU gives us 2.02 AMU worth of hydrogen. We got 1 oxygen. If we look at the periodic table of elements, oxygen has 16 atomic mass. So we got 16 AMU, and that's not a 10, that's 1 oxygen. So 1 times 16, or we got 16 AMU of oxygen. Add those together, and the atomic mass of water is 18.02 AMU. Now, if we take that and we multiply it by our 1.66 times 10 to the negative 24th, so if we take our 18.02 AMU times, we put that over 1, we want to get how many grams, so we know that we want to get rid of AMUs. AMUs are in the bottom. We want to get grams. Grams on the top, and we know that 1 AMU is 1.66 times 10 to the negative 24th grams. Okay, so just using our scientific notation here, remember 18.02 is the same as saying 18.02 times 10 to the 0. 10 to the 0 is 1, anything by 1 is itself. So let's first of all multiply 18.02 times 1.66, pull up my calculator. Okay, 18.02 times 1.66 equals 29.9. Oops, 29.9. Then when we multiply exponents, we add them. Negative 24 plus 0 is negative 24 grams. That's not right. We got to move that 1. So we're going to end up with 2.92 times 10. Now because we moved it 1, we actually took a 10. We have to multiply this number by 10 to get there, so we have to add 1 there, so negative 23rd grams. So 1 water molecule weighs 2.9 times 10 to the 23rd grams. That's hard to work with, but 18 AMU is much easier to work with. So this will lead you into our next video on moles, something we're going to use a lot. So don't worry about knowing 1 AMU is 1.66 times 10 to the negative 24th. If you need that, they'll give that to you on your test. But the concept of moles is going to be used going forward. So make sure you get the next video down pat. Again, if you have any questions or concerns, just drop me a line at mrc@mrcscience.com.